G'day, how you going? Miss Bennett here. Today we're going to be looking at some problem solving using quadratics. Alright, so here's the first example. So if you have 100 metres of fencing material and you want to make the dimensions of the pen to produce the greatest area. Now, if we've got 3 pens here, we know that we can use 1,000 metres of fencing to make any of those 3 pens. So what I've got here is I've got, in fact, when I start looking at it, I've got 4 x's and I have 6 y's, and that's got to be equal to the perimeter, which is 1,000 metres, don't I? Alright, so now I can rearrange this equation. I could find y in terms of x. So if I said 6y equals 1,000, take 4x, when you bring it across you change the sign, don't you? Okay, and then I could say that y is equal to 1,000 divided by 6 and 4x divided by 6. So I'm dividing both sides by 6. Okay, so that now gives me my y in terms of my x value. Now we want to find the area. The area of this shape is in fact 3 lots of x times by y. Each of the pens x, y, and there's 3 pens, so that has to be my area. So then I can just substitute my value for y in there. That will be 3 lots of 1,000 over 6, take 4x over 6. And I have to keep the x out the front there too. So when I do 3x times there, now I can cancel the 3 with a 6, can't I? So that will be a 2 there, so that's going to be 500x, that first term, and the next term will be take 4x, it's actually going to be over 2, isn't it? So that's actually going to work out to be not 4x, it's going to work out to be 2x squared. Alright, so 2x squared. So that would be 3 times 4 is 12x, divided by 6 is 2. So that's my quadratic equation. Can you see it's a quadratic equation? Hopefully you can. Now, the one thing that we do know about quadratic equations, if we're trying to find, the area, the max and min occurs with the vertex or the axis of symmetry. So what I can say is x equals minus b on 2a. In this particular equation, if we rewrite it as a is equal to minus 2x. Right, so we'll rewrite that as minus 2x squared plus 500. Minus 2x squared plus 500. So that means here that's going to be simply the b value is going to be, it's 500x. The b value is going to be 500, so it's going to be minus 500 all over 2 times by a, which is going to be minus 4. So that means that's going to be 504, which is 125. That's what my x value is going to be. And then I can work my y value by simply substituting my x value into the equation. So my y value is going to be equal to 1,000 divided by 6. Take 4 times by 125. Divide that by 6 as well. Okay, so 4 times 125 is going to be 500 on 6. So therefore it's going to be 1,000 takes, so it's going to be 500 on 6 is actually my answer there, whatever that works out to be in terms of a length. So this is a really simple way to find the max and min. Just remembering we're trying to find the maximum because this quadratic is got a negative value in front of the thing. It's going to go something like this. So we're corresponding to this particular value. Now we'll do some of these questions in class, which will help you as well. Right, second question. Okay, we have the length of a rectangle is 8 centimetres more than its height. what is the dimensions if its area is 48. Alright, so if we just think about that, a rectangle, nice simple shape. We have its height, we'll call its height x, and then we're going to call its length x plus 8. So we know that the area is 48, so area is equal to 48, and that's simply going to be x times by x plus 8. So if I expand the bracket out, I'm going to get x squared plus 8x. I'm going to bring the 48 to this side over here, and that'll be take 48. Rather than writing 0 equals, I'm just going to go equals the area there. Okay, so the area there, in fact, is actually equal to 0 because I brought the 48 across, didn't I? Okay, so that's equal to 0. Now, if I want to factorise this, that's what I need to be able to do. So all the techniques that you've learnt so far, you could use your graphics calculator to graph it and read off the x-intercepts. You could put it into polysym too, and that will actually allow you to get the answer directly, or you could put it to the quadratic formula as well. The quickest way and the easiest way to do it is to simply go, well, what are the factors of 48, and do it the quick way. Right, so factors of 48 are 48 and 1, 24 and 2. Right, then you've got 12 and 4, you've got 6 and 8, and so on. Now I'm looking for a difference of 8. I think that's the one I'm looking for. Okay, so when I start looking at this question here, I'm going to put in 12 there and 4. I know it's negative because one of these has to be negative. That must be positive there, and that must be negative there. In other words, x has to be equal to negative 12, or x has to be equal to 4. Now, you can't have negative 12 as a distance, can you? Alright, so x has to be 4, so therefore the dimensions of my particular rectangle are going to be simply 4, and then 4 plus 8 is going to be 12. So it's going to be 4 centimetres by 12 centimetres is the dimensions of my rectangle. So this question here is not using the vertice point, but it's using the roots of the equation to work out what are the possibilities for this particular function. Right, so that's a second example. Third example that we're going to do here is the sum of the product. Okay, this is a language one. Again, right, you could probably solve these without actually using quadratics, but quadratics allow you a process where you don't have to think about it and you can apply a formula, and that's a really useful thing to do in mathematics, especially when the equations become harder and the problems become harder. So this is about building some skills up. Sum of a number and its reciprocal is equal to that value there. So we'll call the number x, and obviously its reciprocal is going to be 1 over x. So in other words, the sum is simply going to be x plus 1 on x, and that's equal to 2 and 1/30. Now 2 times 30 is 60, so we're going to say x plus 1 over x is equal to 61 on 30. Now, just letting you know, I don't like fractions anymore. I actually do, I'm a maths teacher, but I know students don't like fractions, so one of the things that we like to do is get rid of them. A little trick that I've learned over the years is whatever's on the bottom line is I can times that by what's on the bottom line. So I've got an x and I've got a 30 on the bottom line. So if I times the whole equation by 30x, that will get rid of the fraction and allow me just to work with an equation. Alright, so that's a little trick that you can use, and it works the same every time. So as long as you do whatever you do to both sides, it's fine. So that will leave me with the first term, 30x squared. The next term, the x is going to cancel out, and that will leave me with plus 30. And then the last term, the 30 is going to count, and that will leave me with 61x. Alright, the next thing I need to do with this equation is to write it with everything on one side. That 61 is going to come across and become minus 61x plus 30, and that's equal to 0. So I'm going to factorise that, and This is probably one that you may go to your calculator to factorise, but I'm going to have a guess because I think I know what it might be. If I have 6x and 5x, that's how I'm going to get 30. And I'm thinking again, 30 as being 6 and 5. Now I'd look at 61, I know that is a really odd number, but that's 25 and 36. So if I put my 6 there, that number there is going to times by 6x. The 5 will be times by 5x, will give me 25x. So therefore, and they're both negative, that should work. Alright? And if you think about it, these inner terms give me 25x minus, the outer term gives me minus 36x, and that's going to give me 61, which is what I'm looking at, that number there. Alright, so that works quite nicely. Now going back to finding a particular answer, alright, so if we're looking at that, that means that the number that makes this 0 is x is equal to 5 on 6, or x could be equal to 6 on the 5. So if you have either of those numbers, that's going to give you that particular answer over there. So you've got two possible solutions. Obviously they're reciprocals of each other, so that makes sense in terms of what the answer might be. Now, you need to practice, obviously, their problem solving, because that's really, I mean, the key concept, if we're looking at using quadratics, we want to use quadratics to solve problems, and that's what we do. Alright, so we're going to use the quadratic equation either using the vertice point for max and min problems, or we're going to use the x-intercepts, the roots, to find solutions for unknown equations. Alright, so good luck with these questions. Hope it all works out for you well and you find this stuff easy. If you don't, make sure you catch up with us so we can actually support you with that.